Hello friends, I'm Mahesh Bandi. Today we are going to see how we basically run our integration server inside a Docker container. So this is pretty much simple. So I think if you can just follow the steps 1, 2, 3, 4, 5 that I have given in this PPT. So it's pretty much easy for us, to simply start our integration server inside a container and make it cloud ready. And also we're going to discuss a simple use case like a designer or a developer who is going to commit the code to git and so we can following some simple commands, we can get the updated code from the git automatically when a container starts. So there's a simple use case that we are also going to discuss. So the prerequisites for this session is going to, we need to have minimum knowledge about the Docker technology, and then we need a Docker engine that has been running. So in our demo, I'm going to use a virtual machine with CentOS operating system, and I have already installed the Docker engine. So probably you can first two steps. It's pretty much straightforward. So we can download the virtual box from Oracle site, and we can download the CentOS ISO, and we can install the operating system. And if you follow the second steps using this link, so it is pretty much easy for us to install Docker engine as a root user. So we'll mostly discuss from the step 3. So step 3 is creating a Docker file, right? So from webMethods version 9.12, so we have a shell script that has been automatically create a Docker file for us, to generate the Docker image for our webMethods integration server. So we basically use that shell script. So we'll basically understand what are the required options that we need to provide to create a Docker file. So for those of people who don't know about Docker file, so it's basically a set of instructions that we are giving to the Docker engine to build a Docker image from that. So once the Docker image has been created, so this Docker image is not the same as like a webMethods software AG image that we use for installation. This is a separate image that Docker engine is going to use it, to run the Docker. So once the image is available, so the next step is going to you're going to start the Docker image, and you're going to create containers. So why what is the advantage we are going to get here? Like if you look into this diagram here, so from a Docker image, so we can create a number of instances or a number of containers. So the one advantage that we mostly get is the scaling. So we within the fraction of seconds, if we have the required infrastructure, we can scale up our integration servers to a number of nodes, and we make sure like at any point of time we have an integration server that is running and it's operating. So before jumping to topic, a small discussion about Docker is basically a Docker is a bare operating system which is available for us to just run our application or any command basically. So it's a minimum operating system that have a minimum set of binaries that are running to run the operating system, and the Docker engine basically start an operating system and execute a command that required for us to complete. And once the command execution is complete, it is going to shut down the operating system. So that way we are going to efficiently, or basically the application that is going to start with a command is going to efficiently use the entire resources that are available in the operating system. And that will be the most difference between the difference between the virtual machine and container based operating system. So in a virtual machine we are going to assign the CPUs, we are going to assign the RAM, and we are going to assign the required hard disk for that, and uh, so those are like statically defined for a virtual machine. But whereas in a Docker or a container, in order to run an operating system, so we basically will not define all these parameters. So at the runtime, it requires the Docker engine requests the operating system to provide the required resources. And if you look at the processes that are running in a virtual machine will be more than the processes that will be running in a Docker container. So that way, as we discussed in the previously, like Docker is going to start from a single command that we are going to execute, and it's going to terminate once the command execution is complete. So that is pretty much important. So the command in our case is going to be simply start in software, so simply start integration server, and probably shut down the Docker once the integration server shutdown is complete, or once the command execution is complete. So in my case, I have already downloaded the VirtualBox, and I have started my CentOS, and that's basically running. So I have also installed the Docker. So first two steps I have already done. So I'm going to start from the third step, which is create Docker file. So if you install, so look at this. So once we install the Docker, so we basically check whether if the Docker engine is up and running by simply, so if you just type Docker images, so you'll be able to see the list of images that are already created in this, basically that are already loaded into the Docker engine here. So a Docker image is just like it is just like an image. So from this Docker image you can create a number of instances. So in order to check if there are any active instances that are running, so the basic command is docker ps. Docker ps will basically give the list of active instances that are running. So currently there are no instance that is running. So if you want to see the previous instances that are ran and that are shut down, so you can use command docker ps fn. So basically this gives like there was an instance which from this image which has started with this command and it was shut down, and the name of this instance is this. So basically this is a dynamic name that is been assigned. So basically if you understand, like the Docker will start with a command and it will shut down once this command execution is complete. So we in our example I have installed the webMethods integration server products in this path /opt software ag, and if you look at this, I have installed integration server, so version 9.12, right? So in order to create a Docker file, so let me, I think there is a Docker file here, so let me remove that. So there is no Docker file now. So in order to create a Docker file, so just go to integration server. So there is something called Docker folder. So here you will find is_container.sh file. So just to understand what are the options that we need to pass for this shell script to create a Docker file. So just run this command. So this command will echo us the required parameters that we need to pass, or just create a Docker image, right? So these instructions basically will give you how do you prepare a Docker file. So once the Docker file is created, we need to use the Docker commands to create the Docker image. So this also we can use the options like docker is_container sh build, so basically to build the required images, right? So the approach generally, if you look into this, is right. We have options like create a Docker file, and we have options like create a lean Docker file. So, and we have option like create packages from Docker file. So there are three options, and why three options are being given, that we need to understand. So if in the first option, so create a Docker for a base integration server instance, including default and WM packages only. So this basically will only copy the default and the WM packages, and this, so basically once you start an integration server inside a Docker, you will only see a default package and a WM package. So it will prepare the Docker file in such a way, it will only copy the default folder and the WM package folder, which are required for integration server to start. So, and look at this, create a lean Docker file. Create a Docker file for a base integration server instance, including default and WM packages that are required for a core integration server. So this command, if you use, like, it's going to add few more packages that are required to build a core integration server. So these are again, it's going to simply copy the required WM packages into the container. So that's the only difference it is. So first step is like we are going to create a base integration server. So either we can use the first option or we can use the second option. So so later, once we create a Docker file, right? So we can modify the Docker file based on the things. Basically, you can verify what folders that are available, and based on that, we can copy the required packages if we require. So let me go and execute this. So I'm going to create a lean Docker file, and I'm going to give an instance. I'm going to give instance name as default, and if you look at these, other parameters, port list name. If you're not giving if you're not specifying anything, it's going to by default expose 5559999 port. And file name, if you're not giving, it's going to simply create a Docker file underscore is, right? So in this case, I'm not going to give anything. So let me execute this. Once I execute this, I am going to get a Docker file that is get created. Super. So where the Docker file get created is like where the integration server install directory. So which is OPT software AG. So let's check here. So it has created a Docker underscore file here. So let's examine this Docker underscore file. So this file says, prepare a Docker image from CentOS:7. So this will be our base image, right? I think there is this, since we have prepared this from an executable script, we need to check what will be our base image. I think it by default creates like CentOS:7, but just check if that is available here or not. In order to check that, Docker images. So I think in my case I have CentOS latest, right? So I need to rename with latest. So let me go and rename it. And maintainer, you can give specify any name. So in this case, I'm going to give some test maintainer. And what are we trying to do? We are trying to copy the required JVM files, and we are going to copy the required jars. We are going to copy the required WStack folders, and we're going to copy the required lib. So basically copy all the file system that is there in our virtual machine integration server, and we are going to name that as a default instance. So all the files we are going to copy, and if you look at this, we are going to copy the default WM root and WM public package. So there's a trick here. So basically, if you want to copy all the WM packages, so you can modify this file. So let me modify this. So I want to copy all WM packages that are available in my virtual machine to the container. So this basically provide or copy all the files. So I'm just overwriting the default generated file, right? So if you look at this, after copying it, I want to run this command to just to create the profile directory in the container. So we are going to use the run command. So the run command basically execute during the image creation, but run command will not execute during the instance creation. So that is something which we need to understand. So only when we use the cmd command or entry point, those commands are going to execute during the instance creation, but whereas run is going to execute during the image creation. So during the image creation itself, we are going to install, or basically we are going to execute or create an instance of this layer. So once this, basically we are not going to change anything that has been generated from the Docker file, so we can leave it as is. So what is the extra that we are going to add in this Docker file is install git. So since I told, like, this operating system is the base operating system, this CentOS latest, it doesn't even have any single application that will be running inside that. So that's a very base operating system. So if you want to install anything else like git, anything, so we need to even specify this. So in order to install git, so what we can simply specify is install git -y. So this basically install git inside this container that we are going to create. So, and we are going to expose 5555 and 999, and we are not even executing any command. So why we are not executing any command? Like, we want to make this as a base image, and once only we copy our actual project packages, so we are going to make that as our final image, and we are going to start our integration server, right? So using this image, we are not going to start our integration server. We're going to simply prepare instruction to create a base image, right? So let me escape :w2. Let me save it. Once I saved it, so I'm going to build a Docker file. So sorry, I'm going to build a Docker image from the Docker file. So I am in the I'm in the software directory. So in order to build a Docker file, so let me rename this to So I just renamed this docker file _is to Docker file. So the reason being is it's pretty much easy for us to build if we just have a Docker file. So I'll just explain that in a minute. So I'm just naming it as is_git:\v1. v1 is the tag that I'm going to give for this base image, and I'm going to put dot here. So what this command does is I'm going to build a Docker image, and I'm going to name it as is_git, and I'm going to tag it with version v1, and I'm going to put dot here, so which means please look up the Docker file in the present working directory. So if you would have used Docker file _is, you need to specify explicitly with -f option. So if you would have just have a Docker file, which is the standard, so you just need to put a dot. So dot will basically look up the Docker file in the present working directory, and if it is present, it's going to take up the instructions from the Docker file and build an image. So once you execute this, you are going to get a Docker image created. So just executed that, and it will take some time to execute the Docker image, since the file sizes are huge. So let me show that how the Docker image has been created. So we just type Docker images. So I basically created is underscore git, and I have tagged it as a base. So uh, I have uh, I have this image that has now got created. So this image has nothing. So basically, if I start this integration server, so it's going to simply have the um, it's going to simply have the what's that, just WM packages inside, that will not have any project specific packages. So in order to have the project specific packages, in order to start our Docker container with our project specific, so we need to create one more Docker file, and we need to specify what are the packages that we have to include in the base from the base integration server image. So in order to create a new in order to create our project related Docker file, so I have created one more Docker file. So let's examine what it is. So basically I am telling, like, this time please pick up make my the updated Docker my updated please make create an image from this base image, which is is underscore git colon base, and I'm just giving maintainer is my name. And I know I'm not specifying any copy commands or any run commands, because all these been already defined in this base image. So what all I need to do is I need to copy the required packages that I want to install um, in the integration server, and I want to start the integration server in the Docker container. So I'm going to simply use this command. So this cmd command is going to start basically execute during the instance creation. So as I explained earlier, run command is going to execute during the image creation, whereas cmd command is going to execute during the instance creation. So it's going to once I build this, so it's going to get all the layers that are there from is underscore git base, so which has all my wm packages, everything. So then it's going to start my integration server using this command. So what I'm telling is please cd to this package, and since I have already installed git in the base operating system or base this operating system, I'm going to do a git clone of my repository. So you can directly put this clone. And what I'm telling is, once the clone is copied to your packages, so I want to copy I'm just copying the required packages from the repository folder that has been extracted, and I want to move it outside the packages, or move it into the packages folder, sorry. And I want to remove the required .git the unnecessary folders that are being created because of this git clone. And finally I'm going to start my integration server using this command. So if you look at this, I am executing this single command, and in this single command I'm clubbing multiple commands, and that is possible. And basically once my integration server will be finally starting with this final command. So this will be our command to start our integration server, and finally we're going to expose the ports 5555 and 9999. So this will be our command. So once this is done, so I am again how to build it. So how do you build again? So just go to docker build, docker build and give the name -t, give the name is underscore. You can give any name basically, but I'm just giving like test repo 1 and followed by dot. So basically if you execute this command, in this case I have already done this, so it's going to create my repository here. So I just executed because just to save time. It's going to take 5 minutes for me to generate this image. So once this image has been generated, so we can now start our integration server. So let's, in order to start our integration server, create an instance of a Docker container. So the command that we need to use is docker run -d. D means run it in the daemon mode, and I want to start, and probably I want to expose the ports, right? So just expose the ports 5555 from the underlying operating, from the, basically this 5555 port is from the virtual machine, and I want to expose the port 5555 5555 of container with this port that is there in virtual machine. So this is our virtual machine port and this is our container port. So using -p option, we are mapping from our virtual machine port to our container port, and finally we are going to start our integration server. So in the, when I'm trying to execute this command, I'm not passing any command, and if you don't pass any command to run this docker container, it's going to take the default command that we have specified in our docker file, which is there in the cmd. So let me go and run this. So if I run this, so it has given me an running id. So let me examine docker ps. You see, like, this is the same id with with the shortened notation. Shows like it's been running from this image and basically started executing from this by running this command, and it's been assigned with the local operating system with the virtual machine port 5555. This is the container port, and just gave a name like pensive. So then the different name basically, right? So the name should be unique. If you're not specifying any name, so docker engine is going to give its own name. So I think, let's see if this docker has been started or docker instance has been started. So how do you basically check that? So you can see like the instance is running, but from our running point of view, let's go and check if integration server is started or not. So how do you check? So since we have mapped this port from our local operating from virtual machine operating system to container, so just check what is IP that the virtual machine operating system is being exposed outside. To take this command, so if you look at this, like this is an integration server that has been started in the docker. So just click on about. You can see the file system that was copied is with the /sag common. So let me check the package management. So if you look at this, so we have copied our WM packages in our base image that has been copied successfully. So as a part of our last CMD, so we are checking out our packages from Git. So if we look at into GitHub, so this is my GitHub just for testing purpose. I created a repository test repo 1 and I have these 3 packages that are available here. So the moment I start my container, these 3 packages are available. So we'll just quickly make some more tests, by checking in some more packages into our GitHub, and let's see once we start how we are going to get the required packages and automatically start our integration server. Okay, before I do that, let me stop it. In order to stop an active instance, this command is docker stop and followed by the container ID. So this instance has been stopped, and now if you just look at docker ps, so nothing is running. So you can just also verify this. So we just execute this, I will not see any instance that are running. So in order to demonstrate this example, so what I'm going to do is I have started my local integration server which is running in our Windows, in my Windows machine, and I have created a designer workstation and connected to that. And in order to do that, so basically I from the local workstation, from the local integration server, I'm going to push echo to the Git, and I'll try to restart the same instance that I have stopped just now, and I'll basically show how the packages are getting automatically checked out from the Git. So let me do that. So let me go back. So this is my designer workstation, and so in this case I have 2 packages which is 123 and 1234 which are already available in my Git here. So let me create one more package. So I'm just creating one more package, and just creating so just create a flow service with few inputs. So again, this discussion is not to concentrate on the flow service logics. So for us to just to demonstrate how do we check in, check out the code directly from Git to our containers, how it's basically is possible. So I just created a demo package, and let me go and just create a local repository, and once I create a local repository, I can just simply go and commit it. So you can either commit to my local repository, or I can push it to the GitHub. So in this case I'm just committing and pushing to my GitHub, so it's automatically doing it. So this is been now pushed. So test demo package 123 is been pushed to the Git. So let me go and refresh this. So if I refresh this, I have received the step demo 1 package. So the moment I start my container, so I need to actually see the required packages available in my container. So let me see. So So if you look at this, there are no active instances that are now currently running. So if you look at the old instance that were run, so I see. So this is our the last instance that we have run, and that was around 8 minutes ago. It was exited, and let's restart the same instance. So in order to restart the same instance, command is docker start, and you can specify a container id or you can specify the name. In this case, I'm going to specify docker start the container id the moment I start it. So if you look at this, now the put docker paste is going to give the active instance. So this instance has been now active, and it's been binded with the container port 5555 with the local virtual machine port 5555. So let us see if this integration server is started or not. I think this is our this is our container integration server, which is again starting. So let's wait for a minute. So very fast it's now started, and if you look at the package managements, you can see our test repo 1 package is also automatically checked out from git and it's been automatically installed. So in our case, like, we are not even deploying it. So this using this simple command, we can the moment a developer check in the code to the git repository, so if we simply start in docker container, so this is automatically going to check out and is going to start the required instance. So if you have multiple docker instances that are running, so automatically this code will be available across all the instances. So let us examine the same from the designer. So let me put this and see if the required code has been properly has come or not. Okay. So just named that as a COINT, and in this case, this was the package that we have. This was the package that we have checked out from the git, right? So this was the maps, and this was the input. So everything is properly has checked out from the git, and you can make, so probably from the local repository, you can make any changes, and those will be automatically available across your all containers. So I hope that that we are trying to demonstrate a simple use case using this git. So just to recap this, like, what we have done so far is, we have created a docker file using the required sh command, which is available in the software AG integration server docker folder, and we first created a bare IS bare integration server image where it has only the WM packages, and we are not going to use that for executing. So later we have created one more docker file, and using that docker file, we have provided a command to check out the code from the git and place it into the package folder, and that way we made that the docker file available to start when we are going to start the docker container. So I think hopefully you can start working with the docker, and this session probably will give some idea about how do we basically work with docker and integration server. Thanks for watching.